If black holes suck in matter, then white holes should spit it out, but no white holes have ever been observed. So are they theoretical constructs that don't actually exist, or are they hiding in plain sight? What is the white hole paradox? It all starts with Einstein's general theory of relativity. This theory describes how space and time intertwined into a flexible fabric called spacetime can be warped by the presence of mass and energy. Imagine a trampoline with a bowling ball placed on it. The ball will cause the trampoline to sag, curving the surface around it. This is kind of like how massive objects warp spacetime around them. One of the solutions to Einstein's equations for this warping of spacetime is what we call a black hole, an area in space where gravity is so strong not even light can escape its pull. But the equations also allow for another possibility, a region from which nothing can enter, a true cosmic dead end, or a white hole. Here's the thing, while there are a lot of things we don't know about black holes, we do have some pretty good observational evidence for their existence. We've seen stars get ripped apart by them, do gravitational surfing around them. We've even seen the shadow of one against a backdrop of glowing hot gas. But white holes, well, we've never seen any evidence for those either theoretically or observationally. They just don't seem to fit with our observations of the universe. But if you believe that the universe is simply governed by the laws of physics and nothing more, then you have to admit the possibility that white holes are out there. And some physicists think that these mysterious objects may be hiding in plain sight. So let's start with the basics. What exactly is a white hole? Well, it's a region in space from which nothing can enter. With a black hole, the boundary of this region is called the event horizon. Once anything crosses that boundary, it can never escape the black hole's grasp. For a white hole, the boundary is called the Cauchy horizon. And once something passes that boundary, it can never go back inside. Now, you might be thinking, well, that sounds pretty similar to a black hole. Yeah, me too. In fact, mathematically, a white hole is the same as a black hole. The only difference is the orientation of time. At the boundary of a black hole, time appears to stop completely. No light or other forms of information can escape from inside the event horizon. From the perspective of an outside observer, everything appears to freeze just before crossing the horizon. For a white hole, the same thing happens, but from the perspective of someone falling into the white hole. Their frame of reference, for someone outside observing a white hole, all of the light and matter that disappears past the Cauchy horizon comes from an infinite amount of points inside the white hole. That means the observer outside the white hole will see an explosion of light and matter, like the universe itself is being birthed right there. Physicists who believe in white holes suggest that these objects could be created at the Big Bang or during other high-energy events, such as the collapse of a massive star. It could also be possible that white holes are produced when black holes evaporate. Stephen Hawking famously showed that black holes aren't entirely black. They emit a faint radiation due to quantum effects near the event horizon. Over a long period of time, this radiation causes black holes to lose mass and shrink. Eventually, the black hole becomes so small that the radiation overwhelms the gravitational pull and the entire thing gets flung out into space as a big burst of energy. Some physicists speculate that this process flips the black hole inside out, turning it into a white hole. Now, here's the thing. While we haven't found any white holes, we also haven't found any evidence against their existence. For all we know, there could be white holes all over the place and we're just really bad at detecting them. There are a few reasons for this. First, white holes would probably look very similar to black holes unless you were actually at the Cauchy horizon. All the matter and light streaming out of a white hole would make it visible as a bright spot in the sky. But without a way to measure the exact motion of the objects around it, it would be difficult to tell if it was moving or if we were just looking at a very energetic part of a quasar or some other active galactic nucleus. These are regions around supermassive black holes that emit huge amounts of radiation as matter falls into the black hole. The radiation can extend hundreds of thousands of light years from the center of the galaxy and includes a wide range of wavelengths from radio waves to gamma rays. Second, white holes are expected to be extremely hot. The stuff coming out of them has a temperature related to the surface gravity at the Kachi horizon. Since white holes have such strong gravity, the material near the surface would be heated to millions of degrees. That would mean that white holes would emit a lot of X-rays and gamma rays, which can easily punch through the Earth's atmosphere and reach us here on the ground. But since we haven't detected any unusual gamma ray bursts that could be attributed to white holes, it puts limits on how many white holes could possibly be out there. For example, in 2014, a group of researchers used data from the Fermi Gamma Ray Space Telescope to study the distribution of gamma rays throughout the Milky Way. They found that the number of gamma rays didn't match the expected distribution if there were a significant number of white holes in the galaxy. This study estimated that there couldn't be more than 20 million white holes in the Milky Way, which isn't a lot considering that there are likely hundreds of billions of black holes in our galaxy. Okay, so the temperature of white holes could potentially rule them out as a whole, but it also offers a possible explanation for why we haven't detected any. Maybe white holes aren't out there waiting to be discovered. Maybe they're right under our noses. In 2017, a different team of physicists argued that white holes could actually be wormholes. Wormholes are hypothetical tunnels that connect to separate points in spacetime. In essence, they're shortcuts through the universe. Now, you might be thinking, wait, I thought wormholes require exotic matter to keep them open. Well, yes, they do. But what if the white hole itself is the source of that exotic matter? Let's imagine a wormhole acts like a rubber membrane stretched between 2 points in space. To keep the wormhole open, you need negative pressure to counteract the tendency of normal matter to collapse the wormhole. If the exotic matter inside the white hole is what keeps the wormhole open, then when the white hole ejects that matter, it would effectively close the wormhole. This process would release a huge amount of energy that could power things like quasars and gamma ray bursts. And it could explain why we haven't detected any white holes. In this scenario, the white hole is really the end of a wormhole and the beginning of a black hole. So while we haven't directly detected white holes, the idea of wormholes as white holes is still viable. And scientists are working on ways to test this idea further. One way is to look for a specific type of gravitational wave signal that is only produced by wormholes. Gravitational waves are ripples in spacetime caused by the acceleration of massive objects. When two black holes merge, for example, they give off gravitational waves as they get closer and closer together. A key feature of these gravitational waves is that they get stronger and then abruptly cut off when the black holes merge. But if the merging black holes were actually closing a wormhole, the gravitational waves would continue to get stronger after the merger. That is because the closing wormhole would act like a big cosmic spring, releasing all of its potential energy in one giant burst. Another method involves looking for unusual features in the light coming from quasars. As matter falls into a white hole, it speeds up and heats up dramatically. That means the light coming from the white hole would have a very distinctive pattern of rapidly shifting colors. This pattern would also depend on how much matter is falling into the white hole. And by studying these features, scientists hope to learn more about the properties of white holes and see if they really are wormholes. The white hole paradox is an interesting problem in astrophysics. It's possible that white holes exist, but we just haven't found any yet. However, it's also possible that they don't exist at all. What do you think? Let me know in the comments below. Speaking of what you can do if you want to help support this channel, we have a platform where you can support us for free and get access to exclusive perks such as behind-the-scenes content, early access to videos, and more. Thank you for watching this video. If you enjoyed it, please subscribe. You can also watch more videos by clicking here or here.